Science agrees that the cell is the smallest unit of life. There are still some disagreements, especially when it comes to viruses, but for now, all of life is made of cells. However, what is a cell made of? And so that's where we go back and we need to talk about molecules and how molecules are made of atoms. Later in the year, we'll kind of go all the way up to talk about ecosystems and organisms. But for now, we're just going to talk about how do we create molecules that can then be put together to form cells. So we need a little bit of chemistry review. And we want to start at the very beginning by looking at what is an atom. So an atom is an individual unit of any element. And in just a second, we will see the periodic table down here, and we'll talk about some of the important elements in biology class. But for now, we need to know that an atom is kind of the individual unit. An atom has 3 subatomic particles. It has protons. So inside of the atom are protons, and protons are positively charged, and they also have mass or weight to them. Then our second subatomic particle is neutrons, and neutrons have no charge. They are neutral, but they do have mass. And the 2 of these are going to be found in the nucleus of the atom. Different from the nucleus of a cell, but still talking about the core, the center. So these 2 subatomic particles have mass, and they're kind of represented here in the nucleus of the atom. And then our third subatomic particle is electrons. And these are negatively charged, but they have very little mass, basically no mass or no weight. And so the protons and the neutrons are kind of in the center. We won't be focusing much on these this year. Neutrons are going to be come into play when we talk about isotopes and different weights of the individual atoms. But what we're really going to focus on are electrons. So we need to remind ourselves of some of the properties of electrons. Because they are negatively charged, they are going to be attracted towards the nucleus of the atom, represented here, protons with the purple and neutrons with the pink. And so here we have hydrogen. Hydrogen has 1 proton, no neutrons, and 1 electron. So this electron is going to be attracted to the nucleus. But the electrons are also going to repel each other. So as you get more and more electrons, they're going to repel each other. We put them in what are called orbitals, and that's what these little circles represent, the orbitals. But they don't stay in one place. They're in constant motion. And so a lot of times they're represented as a cloud. We can predict about where they would be, but they're never in one particular spot. The most important thing about those orbitals is actually that it has to do with how the atom, quote unquote, behaves. So the number of electrons, and we can abbreviate that with E negative, determines the behavior. We don't necessarily want to give atoms human traits. We're not going to anthropomorphize it, but they do behave, they do interact in certain ways. And so the number of electrons determines the behavior of the atom. And the main thing that we're going to talk about in terms of behavior is, will it bond or will it connect with other atoms? Will it come near other atoms? And it really has to do with those electrons, especially in what we call the outermost orbital. And so one of the things we need to know is what's called the octet rule, meaning that when we have 8 valence electrons, or outermost electrons, we are stable. And so each atom is kind of trying to get to that stable position, and so it might bond with another atom. They might share electrons. they might donate electrons, they might accept electrons. And that's what we're going to kind of talk about with the bonds a little bit later. But we really need to focus on, is this atom stable? And how far away they are from 8 is going to determine that. And so we want to look at a couple of examples that are important to biology. So we go to our periodic table. And we're going to focus in mainly on 3 different elements. Now here you have your noble gases, your inert gases. They don't really react, and so we don't see them a lot in biochemistry or organic chemistry. What we're really going to actually be focusing on is hydrogen, carbon, and oxygen. Now there are 6 essential elements for life. All living things contain chenops, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And we'll be talking about these more a little later. But for now, we're really just going to focus on carbon, hydrogen, and oxygen. Hydrogen has 1 proton and 1 electron, and that's it. And so what we see is that hydrogen is never even going to get towards that outermost orbital. But it's going to be happy maybe having 2. So it's trying to reach 2 so that they kind of balance each other. And so hydrogen, what this tells us about the behavior, is hydrogen is likely to form a bond so that it has 2, like H2 gas. Okay, then we see carbon and oxygen. Carbon has what are called 4 valence electrons, which means it's halfway there, it's 4 away. It needs 4 more. Which means, what's really important, is that it's usually going to form 4 bonds. So for example, CH4. Each hydrogen is now sharing an electron with carbon. Carbon's happy, hydrogen's happy. And so carbon is kind of in the middle. It's not really aggressive about giving or taking. But who is oxygen. Oxygen has 6 valence electrons, which means it just needs 2. So it's very aggressive, very active. What we call that is actually electronegativity. Electronegativity, I ran out of space. And what this means is your affinity or how much you attract electrons. So oxygen is very electronegative. Now these ones with 7 are the most, but oxygen is highly electronegative, which means it's going to attract electrons very actively. So we're going to kind of focus on these 3 molecules, and we're going to talk about them a little bit down here. So when we talk about these electrons and what is happening to the electrons, we're actually talking about the likelihood of forming a bond. Now, a bond is either the transfer of electrons or the sharing of electrons. So we have 2 main types of molecular bonds forming a molecule, putting 2 atoms together. 2 different types. Ionic is when we transfer. One donates, one receives. Covalent is where they're going to share. So we're going to start with ionic. This is where we have an atom with kind of an extra electron, maybe like hydrogen, and an atom that's just missing one, like chlorine. So hydrogen has 1 electron, chlorine has 7 electrons. And so what's actually going to happen is that the electron is going to be transferred to the chlorine, and the chlorine will become negative. Chlorine now has 8. Hydrogen now has 0, it's just an H plus ion, and we form hydrochloric acid. This is actually also what happens with sodium and chlorine to form table salt. These opposites, positive, negative, attract and form an ionic bond because we call charged atoms ions. Positive ions are cations. The T makes me think of positive, and negative ions are called anions. And so an ionic bond is a fairly strong bond because we've got the negative and the positive, but it's easily what I call distracted. Meaning if another positive comes by, we get what are called displacement reactions, where one replaces the other. So the molecule is not very stable. And when we talk about hydrophilic and hydrophobic, this will kind of come into play also, because these will do what's called ionizing, or breaking into the ions. So ionic bonds are important. The ones we're going to focus on more in biology are covalent bonds, because these are stable and kind of long-lasting. So what is a covalent bond? A covalent bond is when the electrons are shared. So I've got two atoms, and instead of one giving and then being negative and positive and attract, they're actually just going to share them, meaning the electrons spend time in both of the atom's orbitals, here or there, back and forth, not necessarily one place or the other. And so these electrons being shared form this or together, covalent bond, and it's pretty stable because the electrons are being shared. Now it turns out that just like when you're a little kid, sharing isn't always equal. Sometimes it spends more time with one of the atoms than the other. And so how well they are shared is going to depend on the electronegativity. If one atom is more electronegative, we're going to have what's called a polar covalent bond. We'll come back to that in just a second. If both atoms are equal in their electronegativity, equal electronegative, equals a equal sharing, and we call that non-polar. Now let's look at this word pole. Think of the poles of the Earth. So the poles of the Earth means sides. Is the electron on one side or the other? So when both atoms are equally sharing it, it's non-polar. The electrons are being shared equally. But when one atom is more electronegative than the other, that pulls the electron over. So that maybe the electrons are always spending more time over here than they are over here. And those are called polar covalent bonds. And I want to give you a really important example, which is with water. So water is H2O. There's our oxygen. Here are our two hydrogens. Our hydrogen, remember, has one electron to share. So these two electrons are being shared with the oxygen. However, oxygen is very electronegative. It's going to really pull those electrons so that the electrons end up spending more time towards the oxygen. Well, this gives us our pole. We're more negative up here. We must be more positive down here. We actually call that a polar moment or a dipole moment, meaning that we're slightly negative up here, slightly positive down here. And so this is called a polar covalent bond. Still sharing, but just not equal sharing. So not equal sharing. And this is going to become important because when I put two water molecules next to each other, the positive side of one is going to be attracted towards this negative side. And the oxygen is going to be repelled. And it's not negative, it's a dipole. So it's not an ion. So this is kind of the main idea that we need to know. Water is a really important compound. We're going to be building compounds. We're going to be transferring electrons in redox reactions. We need to know what an electron is and what a bond is. And so we're going to pay a lot more attention to